This is my first EMA capable antenna. I designed it for use with Aurora mainly. It cannot be pointed in all directions because the house is too close, but it was a quick experiment and it was designed with software and very critically optimized for maximum gain and to fit in this particular place. Here is another view of it. And here is the tiles of the feed point. As you can see, the boom is from wood and the elements, they are attached to the boom with nails through the aluminium, soft aluminium. This is the summer of 1993. I'm mounting the very first element of my new 4x14 element cross Yagi. And here, a little later, it's almost finished. Only a few elements. And finally, the box with the amplifiers, preamplifiers inside there. A very short distance from this box up to the feed point here or here. Now it's time to raise the tower. And here's the way that I'm doing it. You can see the tower here is a little bit on its way up. I think you can see that. And this machinery, I don't know what you call it, but it's hand driven. And here it is, ready for use. This is the arrangement of the feed point. It is sleeve balance made from sheet aluminium. You can see here it is bent to fit around the coaxial cable, and there are a couple of very small Teflon spacers inside. Maybe it is more visible in this image, while you don't see the actual feed point here, but you can see the balun. Here is the inside of the amplifier box. Amplifiers and the cables, the delay lines, used to change the polarization, one linear or the other, or circular one way or the other. And these relays, I don't remember what they are called, something 400, capable of 400 watts, but they do take much more if you don't use hot switching on them. There have been problems over the years. This is in January 1996. There is thick snow on the elements and the antenna doesn't work in this situation. It is very narrow banded and very high gain for the size. The booms were made from soft aluminium that I found in the local junkyard. They were not straight when I brought them home, but I could straighten them. And this was after a storm, and there was no problem bending the tube back to its normal shape. I don't remember which year this was, but it was sometime in the middle of the lifespan of this antenna. This was another problem. A couple of birds on the element tips, like that, would detune the antenna completely, but they wouldn't sit on the lower two antennas, so it wasn't completely useless in these situations. But there could be really many birds, as you see here, and it did have a severe effect in degradation of performance. Here is the solution to the bird problem. There is a dead bird of the same kind hanging here, and then the other ones wouldn't come anymore. The antenna lasted from, I think it was September 1993 until November 1999, when there was a very severe storm. And as you can see, this time the antenna was beyond repair. And here is another picture of the same disaster. This is the cavity amplifier I was using. It has a QBL 5/3500, I think it was called. The diameter here for the cavity is about 1.2 meters. It has a very low profile. What you see here is the pin diode switch. Because I had a radar function, I could see the echoes of everything. Moon echoes or meteor echoes or aurora echoes. That was really fun. And here is the grid side of that amplifier. And the power supply. The main transformer with a motor on it would regulate the power, and this would set the screen grid voltage as a fraction of the plate voltage. This is the controls for the antenna, the rotator, and here is the spectrum analyzer, and here is the camera. It's mounted in the antenna, at the center of the antenna. And here is the center, where I'm pointing. And note how rapidly it turns. I think it was one turn in half a minute, but I'm not sure. And this is the horizon I had. And now I'm going the other way. And here you can see the azimuth indicator. And if you wish to compute how fast it goes one turn. And here is the antenna again. Well, once more, look at this flag here. And I start the video. The center, where I'm pointing. And note how rapidly it turns. I think it was one turn in half a minute, but I'm not sure. And as it turns out, I was wrong. Now the flag is back again. The horizon I had. It was about 15 seconds. So it was a really rapid rotor, and it was very fun using it in the Leonids fireball storm, because I could point to new meteors immediately using the radar function that I had in this station. This is SM5FRH making experimental determination for the boom correction for his vertical antennas. He doesn't have the entire boom, it's enough to have some sections of the boom tube, and he is placing some little extensions until the antenna is correct with the boom tube. So it is exactly the same as computed without the boom tube. And these experiments were done here in my garden, and here you can see him again with this experiment. Tobbe had a really big antenna. You cannot see so much, but you can see it's big. He had a smart system for feeding the antenna, not having one cable for each feed point, but feed points connected in parallel with cables that were a multiple of half a wavelength. And if it was half a wavelength, the phase would be inverted on the feed point. That was a full wavelength. It would be the same direction for the feed. And here you can see the very highly optimized vertical antenna starting from the structure that holds the antennas. So behind this tube there were only horizontal elements, but the gain was not different much between vertical and horizontal because of the higher optimization of the vertical elements. The side lobe levels was a bit higher, of course, but the total gain didn't differ much.